everyone.
How's it going?
My name is Purcell, and I'm here to present to you crafting catchy computer art with Python Turtle. So just for a quick overview of myself, I'm a software engineer. I write a lot of books, so I self-publish 4 books, and I consider myself a creative entrepreneur. Okay, so why this talk can unveil a new world of possibilities? Let's hope that this lives up to the hype. Okay, it's perfect for educators. So if anyone happens to know an educator and they want to find a way for students to stay motivated in programming, I would definitely recommend Turtle for that. And it's also suitable for artists, designers, or any creative folks that want to learn programming but can't find a motivation to stick with it. I also consider it excellent for those who are completely new to programming and are having trouble mastering the fundamentals because, let's face it, programming can be kind of abstract at times. So this is a solid way to master data types, data structures, iteration, and also thinking algorithms as well. I think I butchered that word. And it's also great for beginners that want to code something that they can actually showcase to maybe their friends or family. So that's my selling points on why you should learn Turtle. And here's a quick image to showcase a very simple program that you can write with Turtle. As you can see, a green turtle is printed to the screen, and it's a good way to kind of like get started and learn the basics. So here's the code on how to do this. Okay. So the next thing we're going to do is we're just going to step through this basic program line by line. So don't worry about memorize this. We'll go through this very quickly. So the first statement was to import Turtle. So if you have Python installed on your machine, then Turtle is there by default. It's wired into the core, meaning that you don't have to install a third-party package. So you can simply just do import Turtle, and that's it. Next step is to go ahead and call the Turtle constructor. So right here we have a variable. Okay, there we go. Right here we have a variable just called Leonardo, and it's calling the Turtle constructor. So now, inside this variable, we can use the functionality of Turtle. So next we call the shape function. Shape is a built-in function in Python, and that allows us to create that turtle shape that we saw. And then the shape size function, what this does is it allows you to set the dimensions of the turtle. So the first parameter means the width. So the turtle is 7.5 pixels wide. And the second parameter corresponds to the height. So the turtle is 7.5 inches tall. And then we can modify the color of the turtle. So most turtles are kind of like green. So what we want to do is call the color function, and then pass in the string argument of green. And then last but not least, we need to call the done function. And what this does is it starts the event loop, which in essence called Tinker's main loop function. Tinker is a built-in GUI application in Python, and I did this talk about it this past Tuesday. I think I see some people in the crowd up there too. So thanks for coming out to my talks. And then, so yeah, so that's pretty much it for that basic Turtle graphic. And right here is a link to some of the cool functionality of Turtle. If you want to just kind of analyze the API and see all the functions and the cool things that you can do with Turtle, this is the link. And I'll make sure to provide a link to the slide deck after the presentation as well. Okay, so now that we got the basics of Turtle underway, the next step is let's go ahead and do some cool things with this, right? Let's go ahead, just do some art, let's have fun, let's get creative with it, and let's see what we can draw with it. So, my motto is, I think that a lot of interesting artwork, some of it can be reduced down to a lot of interesting shapes. It could be squares, it could be triangles, it could be circles, whatnot. And by using a couple of simple algorithms, you can create something that lifts a relatively simple shape like a square, and you can make it into something that looks complex and something that's a little bit more interesting. So that's what we're going to kind of explore right now. So the first question is, how will you define a square? Let's just take a trip back down to school in geometry class, and we learn all the shapes. We learn squares, circles, etc. How will you define a square? Anyone like to give the input about that?
Equal size.
I'm sorry?
All four
4 equal sides.
Yep, all 4 equal sides. Yep, that's exactly what a square is. And also 4 right angles as well. So that's the definition of a square. So the next thing is, how can we translate this definition of a square into some code and actually draw the square to the screen? So here's a simple image that we're going to create right now. Just a simple square. Nothing fancy for it for now. And then here's the code for it. So we can step through this line by line. So the first step is to go ahead and import turtle. So like we did with the very first image, just import turtle so that you can use all the functionality inside of the turtle module. The next step is to go ahead and call the turtle constructor right here. And then what we're going to do right now is we're going to hide the turtle, because what this does is, if we don't use this, then it's a little icon that shows up in the final image, and we don't want that. So that all this does right here. Then next, we're going to move the turtle forward 100 pixels. That's what this does right here. So forward is one of the many built-in functions in the turtle module. And then square dot right, what this does is it turns the turtle right 90 degrees. And then this repeats 3 more times. And then finally, we call the turtle dot done, and the image is generated to the screen. So this is the code to create a square in Python using the turtle module. But we can kind of update this code to make it a little bit more, I guess, user-friendly, because if we go back, we'll see that there's a lot of repeated code, right? We go forward 100 times, and then we turn right, and then these 2 statements right here, they're repeated again several more times, 3 more times. So what we can do instead is we can just keep the same logic, but just wrap it inside what's known as a for loop. So a for loop in Python allows you to do repetitive steps. So in this case, what we want to do is we want to iterate up to 4, because there are 4 sides to a square. And then the same logic that we move forward 100 pixels and turn right 90 pixels. So the logic is pretty much the same. The only thing is we have less code because we're wrapping those 2 statements inside of a for loop. Anyone have any questions up to this point? Okay.
Is there a reason you're hiding the turtle?
Oh yeah, because we don't have to do it, but that little icon, if we don't, it will appear in the final image, and it may be a little distracting. So yeah, that's the only reason why I hide the turtle. Okay. Okay. So far, we created the square image, and as we saw, the square image is kind of mundane, right? It has no bells and whistles to it. So we can spice things up a little bit, and what we can do is just add color to the images that we create. So the good thing is, inside of this is a link inside of the turtle module. Like I said before, I'll supply this slide deck to you guys so that you have this information afterwards. But in the meantime, this is a built-in function for the turtle module. And what it does is it allows you to add color to your image to make it more interesting. So that's great and all, but I personally like to, when I'm creating images, I like to randomly generate randomly generate colors, because sometimes when you create an image, you may not know what color scheme looks the best. So I created an open source module for that. It's super simple, and I call it the PyRandom Color open source module. So it's on PyPy. This is released under the GPL license. It's super simple. It just includes several functions inside of a Python file. And if you want to install it, here's all the steps to do it. You can use pip if you have Python installed, or if you have Git, you can just clone it as well and just add it to the whatever files you're And here's just some of the functionality of PyRandom Color. As you can see, you can randomly add color, or you can add color depending on certain hues like grays, blues, greens, etc. So let's create a square portrait like the below. Okay, that's not too bad. All right. So I'm going to just take a detour and go to the terminal so that we can run it and see how Turtle kind of works in action. So I'm going to go. Okay, so we can see it kind of happen in live time. So this is how Turtle works. Just draw it in shape. there, and since I'm using the randomly generate color module, just try to remember this image. I'm going to rerun the program again, and we see how this works. And kind of the same. Okay. So as you can see, every time it runs, it selects colors from it randomly generates colors. So the cool thing about this is it's kind of like randomly generated art. Every time you run it, hypothetically, it should look a little bit different because the colors are randomly generated. So it's not. So it gives a lot of different color variation. I think it's kind of cool. All right. So back to the registration. Oh gosh, it recessed it back. Okay, there we go. All right. So the code to do that, right? So everything is. So the first step, as again, we have to import the proto module. So we've done that, and we're going to import a function from the random color open source module that I created. And then we call the turtle constructor, and as again, we can hide the turtle. You don't have to, but if you don't, just remember that the turtle icon, it shows up in the final image. So I kind of find that a little bit distracting, so I like to hide it. And then what we have right here is we have a nested loop. So we have a for loop, which is the outer loop, and then inside of it, we set the color of the square, and then we use some of the built-in functionality inside the turtle module. So, for example, the begin underscore fill, what that does is this pretty much tell the turtle module that we want to start creating an image and just fill it with the color, and it has to have a corresponding underscore fill function, and these accept no arguments, so there can't be nothing inside of here. And then inside the nested loop is where the square is created. So the same logic that we saw before, that we move forward 100 pixels and turn right 90 degrees, and turtle.done to make the turtle image stick on the screen. Because if we don't include this, then what will happen is that the turtle would generate, and then once the program is finished, it will disappear. So we need to call this in order to get the image to stick. Yep.
How does begin fill work?
Yeah, so pretty much when you want to fill in the color of like an image that you're creating, especially when you're using inside of a loop, you have to call the begin underscore fill function before the final image is generated. And then once the image is generated, it has to have a corresponding in underscore fill function as well. So these two.
What was the last part you said?
The in underscore fill. The begin underscore fill, it has to have a corresponding in
Sure.
function. Yeah.
Does it have to be the same exact spot? Or?
It depends on the code, because it can't. If you put it inside of these statements right here, it wouldn't work. It has to go outside the loop. It can only be called once within the loop. So yeah. Any more questions? Oops. Okay. So right here is another square image that we'll create, and in this case, what we're going to do is we're going to just think of the algorithm for this. So this looks like a relatively complex algorithm, but I mean a relatively complex image. But all this is just squares, and they're just kind of like stacked on top of each other. So that's all that is.
Cool, I got it.
Yeah.
Can you slow down the rate of animation and watch it draw?
Actually, I can. Yeah. Okay. What I do is I'll go ahead and run this, and I'll go ahead and make a. Let's see. So I'll just open up Notepad, which is not the most fanciest thing, but it's a job done. So I'm doing some live coding right now, so bear with me. All right. So I have to first find the file. So go to chapter 4, and oops. Okay. So here's the raw source file for this. So if you want to just slow it down, what you have to do is increase this right here, because when you set it equal to 0, that makes it generate the fastest possible. But if you increase this number, say to like 20 or something, then it slows the drawing down. So we can, actually what we can do is we can run it at 0, and then run it at 20, and then we kind of like, compare it to each other. So what I'll do is, 0. And also bear in mind that this may also depend on the hardware on your machine. Like this is not a very upgraded hardware stack I'm using right now. So maybe if you have like a very fast processor or GPL, it can run faster as well. So just keep that in mind. So that was at 0, and now I'm going to increase that to 20, and we can just kind of compare the difference.
Looks the same.
It was about the same, right? Well, let's try something. So yeah, like I said, depending on your machine, if they may show a variance depending on the machine you're using. So, all right. So, what we're going to do next is learn how to code this. So, as we can see, the logic is in essence very similar to the previous square that we created, the image. The only thing that really changed is just this right here, the angle at which you turn which you rotate each time. Okay, as you can see in the nested loop, the square is still generated. So that's one thing I like to do when creating images. Sometimes just play with the different angle turns, because you make the angle turn more sharper or whatnot. It can have a pretty big difference in the generated image for something that's just a small minor change. So yeah, the logic is in essence the same, just that this statement right here is different. That's all I meant. So. Okay, so now that we created some images using a square, the next thing to do is, how about a circle? What can we create with a circle? So here's some simple artwork that we can do just using a circle. So right here, what I try to simulate is just like a randomly generated sky. So that all this is, and this right here, just a bunch of circles, bubbles, or whatnot, whatever you want to call it. So that's the cool thing I like about Turtle. I mean, like a lot of art, it's open to interpretation. So whatever type of creativity you come up with, just have fun and experiment. So let's go ahead and code this. So the first thing we need to do is we learn how to create a square in Turtle. So the next thing to do is let's learn how to create a circle. So inside of the Turtle module, you have this function right here, the turtle.circle. And as you can see, here are the arguments. You have a radius, you have extent, and then steps. So the radius corresponds to the radius of the actual circle. That's what this is right here. So if you make this bigger or smaller, that can, in essence, manipulate the size of the circle. So let's first start off with the very basic bare minimum circle, which is this right here. And then here's the corresponding code for it. So as we see right now, we just import turtle, call the constructor, hide the turtle, create the pin size. What that does is it, in essence, operate as a border around the circle. So the 2 represents the 2 pixels around the circle itself. If you put 0, then it won't be no border around the circle. And then this right here means the circle has a radius of 100. And then call turtle.done to make sure that the circle stays stuck onto the screen. And then the next, we can create an arc as well. And the arc is in essence the same thing. The only thing is you use this argument right here, extend equals 150. If you don't include this, what would happen is just that 100 will correspond to the radius. The extent helps you to create the actual arc, just like another argument that's available inside the circle function. Okay, so now that we understand how to create a circle, do anyone have any idea how we can create that randomly generate night sky? Just this simple image right here. Okay, so first thing I'm going to do is just demo it right quick. So I have to exit out this image and just call it right here. So here we can see that the turtle is working very hard just to randomly generate the night sky. And since there's 1,000 circles that will be generated, it's going to take some time. So, but nevertheless, we're also using that randomly that module that randomly colors the images. So what this does is we can also, every time we run this file, the image should look a little bit different. But since it's just a bunch of circles, you may not notice the difference. But it uses various hues within the open source color module that I created. Okay, so while that's running, we can get back to this right here. So far we know how to create circles, and we also know how to randomly color the objects. What we don't know is how to change the background color of the screen, or how to randomly position various circles on the screen. So these are two things we need to learn. And so how do we change the background color? We can use this snippet of code right here. Screen is a class inside the total module, and it has this method inside of it. And what this does is it allows you to set the background color of your screen. And then also what we want to do is, not only do we want to randomly generate the color and even the size of the stars, we also want to randomly distribute them throughout the screen as well. Because if we don't, then what could happen is we could have a bunch of circles just pile up around a certain area. So we want to randomly distribute the circles across the screen so that it looks something like a night sky. So in order to do that, we have 3 new functions. We have pin up, which picks the pin up and no drawing happens. And then we have the pin down function, which corresponds to putting the pin down. And then the go to as well, which accepts 2 arguments, and it allows you to move the turtle to the XY coordinates. So another way to think of this is just imagine that you have a piece of paper in front of you and a pen, and that you want to sketch something. So you're chilling at your desk and just drawing a masterpiece on a blank piece of paper. What would happen if you decide to pick your pen up and move it to a different position on the same paper? What will happen is that the pen will appear at a spot, and when you put the tip of the pen back down, this is when the drawing happens. So just think of like you pick up the pen and you put it at a different location on your paper, and then you're drawing something. And a similar logic applies to Turtle, because the pin up and pin down methods, they operate in a similar fashion to how you draw on a piece of paper. So when the pin up function is called, the pin is actually similar to when the pin is in the air. You just pick it up and move it into a different location. And then when you put the pin down, the pin is on a piece of paper. When you put the tip of the pin on the paper, and that's when the drawing happens. And this is very important, because if you don't use the pin up and pin down functions, then what could happen is that the pen can move to that new location on the paper, but if the pen is not picked up, then the lines will kind of follow you in that new position. And the same exact thing happens in Turtle. If you don't use them, then you get like unwanted squiggly lines that follow you to the new location. So here's the night sky solution. So what we have right now is this right here is a function, and the stars equals 1,000. That's just that's known as a keyword argument that it sets the default, how many default stars will actually gets printed to the screen. And then we call the turtle constructor. And then we call the screen constructor as well, so that we can set the background color. And then what we do is we just create a for loop, and we want to iterate 1,000 times, because we're iterating. We set num equal to stars. We created another variable, and then we're going to iterate up to that amount. And then what happens is right here the pin is picked up, and then we want to randomly position that circle at this location right here. And the reason why I picked from -300 to 300 is this is more so like a trial and error. Like I guess it's like an educated guess, a better way to put it. But it's dependent on the screen size. I wanted to create an image that falls within the parameters of the output image itself. So after this trial and error, I figured I like the way that anywhere from -300 to 300 look good. So just to clarify, what this does right here is a go-to function, and these 2 arguments corresponds to the XY coordinates For example, if you're graphing something on a Cartesian coordinate system, you have the x axis, which corresponds to the horizontal, and then you have the y axis, which corresponds to the vertical. So what this does is it allows you to put the object randomly from anywhere from -300 to 300 on the x coordinate, and then anywhere from -300 to +300 on the y coordinate. Yeah.
Where did you define the size of your sky, for lack of a better term?
That's done for you by default in Turtle, and I think what they do is it's contingent on your screen size. Just there's a lot of different type of monitors. Some monitors are big, some monitors are small. The Turtle module itself, when you call it, it automatically sets it for you. You can change it. There's
Well,
a
I was just
function in
saying,
here.
you're using -300 +300
Yeah.
to randomly position
Yeah.
the pen, right?
Yeah. No.
Does that
no,
mean
actually,
that it's always
wait.
gonna be in a 600 square pixel image for your sky?
No, because in this case, like it really depends on your computer screen. Like I said, that this after experiment on this computer screen I'm using right here, this is the number I came up with just by trial and error. But if you're using like a smaller or bigger computer screen, things will be positioned really differently.
But I mean, but what is that number? What is that number you're passing in?
This right here.
Is it a pixel or is it a?
Yeah, it's just imagine that the computer screen itself is on a Cartesian coordinate system. If this say that the randomly generated number is -5, what this does is it positions that object at the -5 position on that portion of the screen, and assuming that this is 100, it positions it at the +100 portion of the screen. So just imagine that your computer screen is XY coordinate system, and that this right here, this corresponds to those particular portion of the screen.
Is there an option for the screen, Turtle.screen? Are there options that you may be able to use to set that? Or is that always going to be automatic?
Yeah, I believe so. I don't want to say, I have to double check myself, but I believe there are functionality that allow you to set the screen size. That's what you're asking?
Yeah.
Yeah. Yeah.
Do I need to import TK enter?
I'm sorry?
Do I need to import TK enter? I'm kind of going back. Because this
Oh.
runs on top of TK enter.
Oh yeah, that's right. When we call Turtle.done, this calls the event loop for Tinkerter, because this it sets up the event loop for the graphics, and it's the same exact one for Tinkerter, which is the GUI processing framework for Python.
So to be clear, like do I have to import TK enter?
Oh no, you're good. You just need
Just
to
import
import
Turtle.
Turtle. Yeah.
And that'll import TK enter.
Yeah, we'll call it. Yeah, behind. Yeah. Okay, so what we can do next is that we can go ahead and create more circle art, and this in essence is pretty much the same logic that we use to randomly generate the sky. The only difference is that the colors are different. The circle is not just within the same hues. It's you can randomly generate all types of colors. So, and we can go ahead and run this as well.
There is a screen size method where you can go ahead and set
Okay,
the
cool.
canvas width and the canvas height.
Is it in pixels?
Yeah, it's in pixels.
And
Yeah, in
wild.
pixels, yes.
Oops. Misspelled Python. Okay, so here's the next image that we created. So like I said, the logic is in essence similar to the one we just used for the randomly generated X guy. The only difference is that actually there's two differences. We're using bigger radius sizes, and we also have a wider color scheme that we're picking from. So, oh yeah, so for some reason I couldn't get all that code to show up on So everything's on GitHub, and like I said, I will make this code available after the presentation. So, okay. So another thing that a modification from this code compared to the last one is that I wanted to have a wider distribution of circles. So what I did was I used these built-in methods from the turtle class that allows you to get the length of the screen and also the height. So here is a loop, and it generates 500 times. And then what we do is we randomly assign the location of the turtle object, the turtle pin, and then we fill the circle.
Can you zoom in, please?
Okay, cool. And then we also call the circle function, and we pass in the radius. And the radius is also, it's randomly generated within some 5 pixels to 50 pixels. So we have a bigger distribution of the size of the circles, and we also plot them on a wider distribution as well in the screen. So do anyone have any questions about this image that we created? Okay. And we can continue with, once we know how to make the circle shapes, we can continue making interesting artwork with it as well. So in this case, what we're going to do is, this is like a spirograph, and spirograph is I think it's a tool to use to create interesting shapes. So in this case, we're just going to have a bunch of circles that just interweave around each other. That's all this is. So just a bunch of circles. And we can test this out. So here it is in action. So as you can see, it's just a bunch of circles, and it keeps like turning every iteration. Okay. So here's the solution to create this. So a lot of the stuff is more or less the same. We import turtle, and then we're importing this functionality from this module that I created. We're creating a function. We are setting the background color of the screen. We're setting the size of the pin, which again sets the pixels, it sets the width of the circle that's generated. And then we're going to iterate, in this case, 100 times, because the default number of cycles that's created is 100. And then what we're going to do is we're going to randomly color each circle using this get random color function. And then we set the radius of the circles. So compared to the other circles that we created, all of the circles will be the same dimensions, because the radius, it doesn't change. And then every cycle we're turning the pin 25 degrees, which gets that like circular rotation in the image. Okay, so we can go ahead and keep creating more interesting artwork just by using shapes. So the first two shapes we use a square, and then we use a circle. So now we just want to use a very basic line. So how to create lines in Turtle? We simply use the forward function. So here's some code, and I'd like to solicit some answers from the audience. Do anyone know what type of image this will create right here?
Octagon.
I'm sorry?
Octagon.
Good guess. That's a very good guess, because it's 8, right? But in this case, actually, it's just kind of like a snowflake, if you will, that what this creates. So let's run this code right here. This will be another image created just by using the line functionality in Python and Turtle. So, as again, I'm not sure if you guys will agree with this, but the goal for me was to create kind of party lights. That what this was trying to create. But like a lot of art, it's open to interpretation. So some people may see different things. So just to let you guys know, that's what I was trying to aim for, but yeah, it may not kind of look like that to some people. So it's artwork. So the solution is on GitHub because I couldn't fit it on the same slide deck. Okay, so this right here is more or less stuff we already saw before. We import turtle, we set the screen side, background color, and oh yeah, this is the screen side function. Okay, so to answer your question, I wrote this code a couple months ago, so I actually forgot a lot of stuff I wrote. So this is exactly how you set the size of your screen. You use the screen size function, and you pass in the 2 parameters. So completely forget about that. All right, and then inside here, we create a for loop. And then what we want to do is, this right here, we want to randomly assign the X and Y position of every party stick that we created. And this right here, this sets the pixels, and this sets how wide the image you create is. And if you were to experiment with this, if you were to make this 20, you can make the output image look a lot different. And that's where the next image that we're going to do showcases. But just to finish describing this right here, so yeah, this code repeats 200 times so that it distributes all the lines throughout the screen and in different colors and at hopefully different positions as well. Okay, and then what we're going to do next. This. So this is in essence the same exact logic, and what I was going for right here is I was trying to create like jelly bean like candies, like Mike and Ike or Good and Plenty image. So this is what I came up with. I'm not sure you'll agree with that or not. So the code for doing that is again on GitHub, but more or less the code is identical to the previous one. The only thing that changes is this right here, the pin size. What we did is that we increased the border of the actual line that's generated. So as you can see, if you increase it, it'll be like a bigger looking object. And it went from a party stick to a Mike and candy. So that's what I was trying to create. So. Okay, so there's one last thing I want to showcase with Turtle, and I want to create a very simple racing game. So I call this the 4 little turtles. And the object of the game is you have 4 turtles of different colors, and they start off at one portion of the screen. A countdown timer starts, and then once it gets to 0, the turtles start racing to a finish line, and the turtle that gets there first does a little victory dance. So that's the object of the game. And here are some little screenshots from the game. As you can see, we have 4 little turtles on the left-hand portion of the screen. We have a countdown timer, and then we have a finish line. And then the turtles start racing towards the finish line. And then last but not least, the program needs to determine the winner. And then the winning turtle does a victory dance. Oh yeah, and plus it grows in size afterwards as well. So, let's go ahead and run this. Okay, do somebody want to pick a winner this time? We can do this a couple more times. Anybody want to pick a winner?
Red.
Red? All right. Anyone else?
Blue.
Blue? Okay, we got red and blue. Let's see. Uh-oh. Yeah.
So your speed is like within the random?
Yes. Uh-huh. And we can do this one more time. Kind of like this. Anyone else want to pick a winner? We can
Red.
go. Red? Okay. Let's hope the red wins.
Red is due. Red is due.
Yes. Good job.
We should place bets.
Yeah, he spends a little bit more longer. Yeah, there we go. Okay, so now that we demoed the simple fun racing game, how do we recreate it in Python? So first step is I like to break down the code into functions so that it's more manageable. So right here we have the constructor. So this right here is known as a dunder, double underscore, because you have two underscores in the front, two double underscores in the front, and two double underscores in the back. And this allows you to initialize the state of your program. And then start turtles. This will set the default positions of the turtles. The finish line, this right here will position the finish line on the screen, and it draws it. The countdown timer, this, the way I coded it started from 5, but you can start it for something like 10 or whatever you want. And then the set underscore turtles underscore speeds, this randomly sets the speeds of the turtles. And I chose within the range of 1 through 25. Oh yeah, it's more. Okay, so turtle underscore race, this contains the logic that gets the turtles to start moving towards the finish line. The victory dance, that's the logic that makes the turtle spin and then grow in size afterwards. And then this right here, this serves as the entry point to the program. Okay, so this right here is inside of the constructor. So what this does is it creates the turtles. So as you can see, oh yeah, so one thing I like to explain first is that you may see that this code looks a little bit different from the code that we've done previously. And the reason for that is I decided that this program is better off using object-oriented programming. It's my personal preference when you're building some program that's a little bit more bigger and complex. It just makes the maintenance a little more easier. So, yeah.
Why is the def in itself, why is it indented oddly?
It's because I copy and paste it.
Huh?
When I copy and paste it,
Okay, so it's supposed to be lined up with, it's supposed to be midway between class and self?
Yeah.
No, it should be along with class, no?
The code, I decided to break this down into, the formatting got a little bit gypped up.
Okay.
So
I just
yeah.
say, so it's not supposed to be like that,
No.
it's supposed to be like just single tagged in?
What I could just do is I could just take a quick break and kind of show you how it looks, because the code is on GitHub. If I get back to you. Okay, there we go. Nope, nope.
The only reason I ask is because Python's indents have meaning that's.
I know. So the right here
Okay.
is how the code's supposed to look. Like I said, when I copy and paste it to PowerPoint, it loses some of its formatting. So, but the code will be available. This is already on GitHub, and I'll make it available to everyone so that they can experiment with it as well. So, yeah, I'll take off for that. Okay. Just bear with me for 1 second to get back to where we're at. Okay, this we go. So, okay. So yeah, like he mentioned, the formatting for this is a little bit off. So this is supposed to be indented, and when I copy and paste it from PowerPoint, the formatting got messed up. But nevertheless, like I said, I'll make sure that the source code will be online. The source code is already online, and I'll do my best to explain it. So right here is the constructor, and everything within the indent constructor, it gets added within here. You're supposed to indent it 4 spaces. And this right here, we create the various turtles. So we have self.blue equals turtle.turtle, and we set the shape of the turtle. And then we all these correspond to the individual turtles that we created. So we have 4 turtles, so we have 4 instant variables that correspond to the turtles. And then what we need to do as well is that we need to set the location of each turtle as well. So we can do that by using this portion of code right here. So we need to position the turtles on the portion of the screen. And then last but not least, by default, every turtle's speed is set equal to 0. And we'll fill in the function, we'll fill in a method that allows us to determine the speed of the turtle. Okay, so on this portion, all we're doing right here is that we're just positioning the turtles on the screen. So as you can see, like the pin up, we have to pick the pin up and then move the red turtle to this position of the screen. Now bear in mind that all the turtles, when we use the go-to function, the first parameter corresponds to the x value, and the second parameter corresponds to the y value. So since all the turtles need to be starting at the same x value, all of these will be the same. The difference is that their y values need to be different, because if the x and y values are the same, then all the turtles will be positioned at the same portion of the screen. So we need a way to kind of just position the turtles at the same x location, but we need to give some variance in the y positions. So all the y positions are a little bit different, so that we can separate the turtles in the race. And this code right here, it creates the finish line. So when we learn how to create the lines in Turtle, what this does right here is just, it iterates up to 30 times, and then it pushes the turtle forward every iteration. And when you move the turtle forward, it creates a little line that just follows it. Does someone have a question? Okay. Yeah.
Can I see the member data? What's it called?
I'm sorry?
The variables inside the object.
The instant variables, this.
Like, where is, so where do you define the red dot, whatever, red dot x and red dot y, and blue dot x and blue dot y?
I define all the variables in the constructor, and then we can modify them throughout different portions of the different methods when it's appropriate. They're initially defined right here, and then they're updated in different methods.
Yeah.
I'm not sure to answer your question.
Because like in C++, you throw down your member variables on the
Yeah.
bottom,
Uh-huh.
but this is not C++.
Yeah, I'm not familiar with C++, but I know in C++ it's statically typed, right?
Yeah.
So yeah, Python's a little bit different because it's interpreted.
Yeah.
So you don't have, there's a little more leeway when you define your variables. Not as strict as C++.
Yeah, you can make it up as you go. But because you went right to the constructor,
Yeah.
and you're like, okay, I want to set this to this other variable, which was undefined from my perspective, right? Because it was jumped to the constructor.
So what? Right here?
Yeah. So if we enter there, the first thing we do is we set.
Yeah, those variables I believe are already defined in the constructor itself.
Because when you create the instance of the class, it starts off here. This right is the entry point to the program.
Yeah. Okay.
So once it runs, these variables are created and they can be used in a different portion of the screen.
So what? Okay, so you're creating it right there. Self.blue is where you're creating it.
Yeah.
Okay. Very good.
Okay. So this is the finish line. It creates the little line that we saw when the program ran. And then also what we want to do is we want to position that text on top of the finish line. So to do that, we use the dot right function, and we can pass in these arguments, which allows us to define the font type and also the size of the font as well. And then the countdown timer. So when we ran the program, it started off at 5 and then count down to 0, and then the program started running. So this is the code for that. as again, this is, yeah, needs to be formatted better. But what we have right now is we have a while loop, and then we start at 5, and then after each iteration, it decrements, or it just subtracts 1. And then we want to pause the program, so we pass in the sleep function, and this causes the program to pause for 1 second. And then it's also important that we clear the message after every iteration, because if we don't, then what will happen is that the numbers will stay. It'll be 5 and 4 and 3 on top of each other. So we have to use the clear function in order to clear the screen after every iteration. And then how do we randomly generate the speeds of the turtles? So Python allows you to use, it has a built-in module, it's called random. And what we're going to do is we create a list right here that generate ranges from 1 to 25. And then we use the choice function from the random module to randomly select a speed, and we assign it to each turtle speed. So this right here is known as a list comprehension in Python. It allows you to, it's like a shorthand syntax for creating a list. A list is similar to like an array in different programming languages. Okay, so here's the logic that gets run. This determines which turtle is the winner. So what we have is a while loop, and the while loop will keep running indefinitely until we pass the finish line. So this is all the logic for that. More or less, it looks like a lot, but if you understand one portion, you understand the rest of these else blocks right here. So what it does is it checks the X position, because the X position when the turtles are racing, that's when that corresponds to like the horizontal portion of the XY coordinate system. So we know that if the X position, whichever turtle has the greatest X position at the end, that's a turtle that has the fastest speed. So this is the logic that tests for that right here. And this continues on from the other stuff from the previous code snippet. This right here and this is all part of the same code block. I just couldn't fit it on the same PowerPoint. And something that's very important is what happens if there's a tie. So what happens if the turtles, the randomly generated selected speeds, if both turtles have the same fastest speed? If that's the case, then there's a tie and we need a way to determine the winner. So in this code block right here, what we're using is a nested if condition. So what this is saying, right, this pretty much checks, assuming that we want to check if the red turtle is the fastest turtle. What we want to do is we want to compare the X value of the red turtle to the X value of the finish line, which is the line that the turtles cross. And if the blue turtle position is greater than the finish line position, and the blue turtle position is greater than the red turtle position, then we know that the red turtle is not the winner. So this is just a nested if condition that checks the other turtles and compare their position at the current time. And then here's the code for the victory dance. All this does is it just loops the turtle up to a certain limit, and then it rotates the turtle a certain angle to the right. And then after the inner loop finishes running, this right here changes the size of the turtle, so it makes it bigger. This portion right here. And this right here just starts the whole program. So when we have everything set up, these are the statements that just starts the program from running. And the full source code is already on GitHub. I said that several times already. I'll make sure to give it to everyone at tomorrow. And thank you guys for coming. And feel free to connect with me on LinkedIn. I'm active on there. And you have a question?
No, could you go over installing PyRandomColor?
Yeah. Oh yeah. Do you have Python installed?
Yeah. I was trying to, and I got an error. That's why I was.
We can talk about it afterwards. I'll be around. Okay.
Well, Doug, books did you author?
Yeah, we got cash, right?
So what?
This is probably where we call you to the trunk and we buy your books,
Oh,
right?
I mean, I'm not saying no to that.
He was asking what books.
Yeah, I
did
was
you
wondering what
author?
books you authored.
Oh,
You said you
no.
offered some.
Oh yes. Oh, okay. I didn't want to do self-promotion because okay, but yeah, I wrote a book about Python. It's
Yeah.
called Become a Python Developer. So it's on Amazon right now. It's a paperback, and actually, this right here, this is part of a chapter of a current book I'm finishing up. That title of that book will be Build Cool Stuff with Python. So what you saw here is a part of the book I'm finishing up. So yeah, I wrote a book on Python, a book on Java, and a book on Scrum and self-publishing. I like writing books. So, yeah.
Thank you.
Yeah. Thanks, guys.
Thank you.
Thank you.